Homework 8.3, starting on page 475, 5. All right, number 1. Okay, so Christopher, if two polygons are similar, must they also be congruent? Explain.
No,
Okay.
because like one could be like say 10, but the other one could be like 5. You could like cut it in half, which makes them similar.
Right, there's a scale factor going on, right? They would be congruent if the scale factor was what?
1 to 1.
1 to 1. Good. All right, number 2. It says decide whether the figures are similar. Explain your reasoning. So number 2, are they similar, Jonathan?
No,
No. Why not?
because the scale factor isn't right.
That's right. The scale factors are different or whatever. They're not the same all the way across. All right, number 3. Zach.
Yes.
And why is that?
The angles are congruent and the sides are proportional.
Yep. Okay. Number 4, David. It says in the diagram you got TUVW is similar to ABCD. List all the pairs of congruent angles and write the statement of proportionality for the polygons. So what did you write for the angles?
And I said that for the statement of proportionality, or
Well, you had to say which angles were congruent to which angles. Okay.
angle in order.
Yeah. Well, I don't know. Angle A is congruent to what?
Angle A is congruent to angle T.
Okay. Angle B is congruent to
U.
angle
D is
U.
W.
hmm
And C is T.
Okay. Good. And then your proportionality statement. How did you put that together?
I said WT is equal or congruent. Is it equal or congruent?
They're all the same proportion, so it's equals. These are ratios, okay? So AB is to what?
WV.
No, AB is to TU. Okay, because you got to make them match up.
I did it in a different order.
Okay, you didn't get them to match up. Okay,
I did
Alright.
it in a different order.
Huh?
I just did it in a different order.
okay, so tell me what you did.
WT is equal to DA is equal to TU is equal to AB is equal to WV is equal to DC is equal to UV is equal to BC.
Okay, but they got to be like proportions, okay? So it's got to look like this. AB is to TU, is BC is to that. Okay, yeah. So you got to have those. They're not equal. Okay, their proportions are equal. Okay. All right. So you got AB over TU equals BC over UV, which equals DC over WV, which equals AD over TW. So David, when you get a chance, I want you to look back at example 1 and 2 and see, well, actually it's example 1, okay, that shows that proportionality statement, okay, at the bottom. All right, number 5, Shannon, it says find the scale factor. So what is the scale factor of those two?
5/3.
Yeah, 5 over 3. And you could also write it as 5:3, right? That's the other way to write that. All right, number 6, find the length of segment TW, Ashley.
10 units.
10. Is everybody good on that?
No.
Yes.
Okay, because what's the proportionality statement going to say for 6? 3 is to 5, right? As 6 is to TW. That's one way to set it up.
Oh, I see what I did wrong.
Okay? You get 3 times TW equals 30, so TW's got to be 10. All right, number 7, Christopher. What's the measure of angle TUV?
810 degrees.
How much?
110.
Oh, 110.
I said 800.
Okay, it sounded like you said 800. I was just kind of like,
I
I don't know what I heard.
like a round.
Okay, so it wasn't just me. Okay.
Yeah.
All right, number 9. Okay, so it says writing similarity statements. Use the information given to list all the pairs of congruent angles and write the statement of proportionality for the figures. So that means you got to write those ratios. Okay, so Jonathan, tell us about the angles.
Angle J is congruent to the angle W.
Mm-hmm.
Angle K is congruent to angle X.
Mm-hmm.
Angle L is congruent to angle Y. And angle M is congruent to angle V.
Good. All right. What were the statements of proportionality, Zach?
JK over WX equals KL over
Okay, or you can say JM over WZ. Okay, good. All right, number 11. Dave, what do you had to do in 11? You had to say, decide whether quadrilaterals are similar and explain your reasoning. So in 11, is ABCD similar to FGHE?
Yes.
Yes, and what was your reason?
I said because they're both rectangles and the ratios are the same.
But yeah, they're proportional. Okay. All right, right, because they all have all 90-degree angles, right? So they all have the same angles and their sides are proportional. All right, number 12, Shannon, what about ABCD and JKLM?
No,
And what was your reasoning there?
their ratio and proportion weren't the same.
Okay, ABCD and then JK, okay, so that they were not proportional. All right, number 13, Ashley.
No, because the angles aren't congruent.
Okay, and then 14, Christopher.
No,
No, and what was your reason?
they're not like proportional.
JKLM and PQ. Okay, well, look at the other thing. Look at the angles. What are all the angles in JKLM?
90 degrees.
Okay, are all the angles 90-degree angles in PQRS?
No.
Okay, and as far as proportionality, yeah, and they're not proportional either, yeah. Okay, so number 15, Jonathan, it says decide whether the polygons are similar. If so, write a similarity statement. All right, 15, are they
Yes.
yes? And your proportionality, I mean, not your similarity statement would say what?
Is that like the ABC is similar?
ABCD,
Okay, yeah, ABCD is similar to EFGH.
right? That little tilde.
Is that
I
all
get
we had to do?
I get confused
Dang it.
between that and like the thing where you put like the
Two.
like the AB over this.
Okay,
over-
okay.
yeah.
Listen, the terminology is different. One is called a similarity statement. Okay, a similarity statement means you're going to say something similar to something, right? So the A, B, C, D is similar to whatever, E, F, G, H is an example. Okay, so you have this tilde there. A proportionality statement is different. Okay, proportionality. Okay, I gotta sound it out. Okay, that's where you're saying, you know, well, AB is to EF as, you know, BC is to FG, you know, and so on and so forth. You're putting a series of proportions there. You see the difference between the two? So you got to look at the terminology of what you're being asked for, similarity statement versus a proportionality statement. Okay. All right. Number 17. Zach, are they similar?
Yes.
Yes, and then so your similarity statement would say what?
XYZ.
Triangle. You got a little triangle shape, okay?
Triangle XYZ is similar to triangle ABC.
Yeah. Now the other thing you got to do is you got to make sure you're putting the corresponding sides in the same order and stuff. So let me just double
It would
check
be
on
CAB.
17. It's actually triangle XYZ is similar to triangle CAB. Okay.
I did it like opposite. I switched the opposite one. So I had like triangle ABC is to YZX.
Okay. All right. But as long as you got them lined up, okay, the right ones lined up with the right things. All right. 19. Find the scale factor of PQRS to JKLM. David.
5/4.
Yeah. 5/4 or 4:5, you could have also said. Okay. 21. Shannon, you had to find the values of W, X, and Y. So Shannon, what was W?
I couldn't get this one.
Okay. So 21. 21. Okay, so you have those they're all, it's kind of nice. They got it all laid out in the same correspondence. Okay, it's not like you have one figure kind of laying on the side. Okay, so that makes it easier. All right, so what are we trying to find there? Let's say we're trying to find, actually let's try to find Y first. Okay, so what could you say? Okay, so there's a correspondence between Y and what side?
PS.
PS, and so the proportionality, you could say y is to PS, which is 16, right, as what? You gotta pick two other sides, that'll work.
So it doesn't matter what side.
Well, they need to be corresponding with each other
Yeah.
and stuff like
Okay,
that.
that's where I messed up.
And so let me just see here. What do we do? Oh, well, I guess you also need to know the scale factor. What is the scale factor? You could also pick two other sides. You could say, as 12 is to 15 or something like that. So,
Isn't the sale factor
okay,
the
so
same?
y goes with the big one. Okay, so the big one's on the bottom. All right. So we're going to say 12 is to 15. You can do something like that. You could also reduce. Yeah, you could reduce this by 3. So what is this the same as?
5 to 4.
It would be the other way around, like this 15
15 would be
on
on top.
Yeah.
Okay, yeah. It ends up being 4 to 5, right? Oh, you're
5 to
right. It's
4.
5. I have the opposite. Yeah, 5 to 4. Okay. All right. So you could also do it this way. It doesn't matter because remember, you got reciprocal properties. Okay, in terms of proportions. All right. So what do you end up with? 4y equals
80 or 80,
16 times 5. Okay, and then you get y equals
20.
Okay. All right, so you get that one. So once you have that one in place, what else are you going to say? You've got, then you got to figure out x, right? So you could say x is to what?
10.
X is to 10 as,
20 is to 16.
yeah, you could pick two other sides, right?
Or couldn't you also use
Yeah,
5
there's
to
more.
4?
I was gonna say there's more than one way to do this. So as long as it all works out and is proportional, but you could say so. The big one this is the big one to the small side, right? Or x is the big one to the small, and then you could say, and you could pick that scale factor again. It's big to small again. Okay. And what do you end up with?
12.5.
4x equals 50. Okay, divide by 4, and you get x equals 12.5. Okay. And then what are you going to do about w? How are you going to find w? Again, you could say w is to 25 as 4 is to 5 again. Okay. Now you get small to big, small to big. Okay, and then you get what?
20.
You get 5w equals 100, so w equals 20. All right, you see how to do that?
Yeah.
Okay. As long as you keep things like either you're going big to small, small to big, and you're keeping the corresponding sides together, the proportion, it doesn't matter how you set up the proportion, it'll work out. All right, 24. So 24, I think it's Ashley. Using similar polygons, quadrilateral or parallelogram ABCD is similar to parallelogram EFGH. Find the scale factor. Okay, so 24, what's the scale factor there?
2 to 1.
2 to 1. All right, 29, it says decide whether the polygons are similar. If so, find the scale factor. 29, are they similar?
Yes.
I'm thinking no, because you're gonna have 18 is to 8 as 30 is to 18. I don't think that works out.
And you can see it because it says 18 is to 14 as 18 is to 8. So
Yeah.
like that obviously doesn't.
Okay, so do you see that, Christopher?
I see the sides. I was just in the angles. But yeah, I see.
It's got to be more than just angles.
Yeah.
Okay, yeah. They're going to try to trick you with that. All the angles, I think technically speaking, the angles are probably not working out either. If they're not, if the sides aren't proportional, you're not going to get the angles to work out. Okay, so number 41.
That's a good jump.
All right, Jonathan. Are they similar? And if they are similar, find x and y. So what is x?
285 over 7. pretty sure that's wrong, though.
I got something different. Let me just make sure I got the right thing.
39.4.
Yes, I got the right thing.
Wait, is that right?
John, what? No, Jonathan's not right.
Wait, no,
Okay.
39.4.
39 and
Okay, what about with the actual fraction? What did you get, Zach, for x?
I didn't leave it as like a,
Just leave it as a fraction.
yeah, I mean, I got 39 and 3/7.
Okay, that's it. 39 and 3/7 is correct. Or 276 over 7. Okay.
Oh, that's
All
right. I
right.
have that too. So.
Okay, you got that? Okay, what'd you get for y? David.
I think I solved for one.
Okay, what'd you get for y, Zach?
Got 162 over 7.
Yeah, 162 over 7 or
Okay, I got that
23
right.
and 1/7. You guys need to see any of that?
Can I
Got
see the
Y
y?
right.
Can I see the
I
y?
see
one?
what I got.
Y is, you're going to set the proportion. Y is to 18
wouldn't it be?
as 21 is to 27. Okay, and then just cross multiply. 27y equals whatever 21 times 18 is. And that's 486. And hold on a second.
378 is 21 times 18.
Yeah, what did I do? I did 18. Yeah, that's right. Times 27. Okay. I got something. I ended up with 23 and a.
Oh, wouldn't it be 27 over 21? Wait.
I'm getting y equals 14.
Yeah, wouldn't
Hold
it be? Wouldn't it be 27 over 21?
Yeah, I'm like looking at this. Hold on a second. Because I'm like, I think I've got it turned around. Yeah.
I got y equals 14.
Oh, okay. So it's the other way around. Right. Is this 486? That's not 486, is it? Let's see.
378.
Okay, I'm not sure what I did on this. I got my proportion messed up.
What was x supposed to be?
Okay.
I think it's
39.
27
I'm gonna
over
drop this
21.
No, not decimal fraction.
Oh no, 39 and 3/7 or 276 over 7.
We
There we
start
go.
over.
I fixed it.
All right, 41. Let's start with something we know. Okay, and I gotta look at the backs. Okay, 27 is to what?
Why?
Y. Yeah, so it's those.
Why?
Okay,
Oh,
27
is that-
they got kind of flipped around. As let's say 21 is to what?
18.
So 20, yeah, the bottom, the shorter side, so 18. There you go.
Can we trust the
Okay,
book?
I wrote, yeah, no, I wrote it wrong.
You can
Didn't
simplify
catch
it.
it. So 21y equals 27
You could
times
simplify it.
18.
You simplify the
You could. And this would be the same thing as what?
or 7 over 6.
Yeah, 7.
I did it the other way.
Divided by 3. Yeah. So you could, so you could do that and you could say 6 times 27, right?
7.
Equals
I think 162.
7y. Okay. And and then you're going to end up with whatever. What is 27 times 6?
162.
All right. Divided by 7.
So it's 23 point something.
Yeah. So it'll be 23, and I don't know which the remainder is.
0.1, I
0.7.
guess.
Okay. All right. Let me fix this in my notes. All right. So now, what's the next thing that you can do?
Like
Find the
for what?
proportion for the.
Because you got to figure out x. So
Were we
what do you,
supposed to put it in 23 and 1/7 or just leave it at
the key has it as a
I
mixed
think
fraction.
I did it.
Okay, I prefer fractions to decimal on some of this stuff, unless it's like a real life thing where you have to come up with,
I think I got it.
number of seconds for something.
Okay, I just left it as 162 over 7.
Okay, there we go. That makes more sense. Okay, now the next one. Okay, so what are you going to set it up? You're going to find x, right?
Which number is this?
This is still 41. Okay, you got to find x minus 6. Okay, you got to find out what x is. So what's your proportion there? X minus 6 is to what?
Is to 39.
x minus 6 is to,
39, right?
is it matching up with 30? Okay.
Yeah. it is.
All right, it's to 39 as what? Well, let's pick 18. Okay, on the other
18
thing
is to 21,
is 18
which you can reduce.
is to 21. Okay? All right, so now what do you get? And again, you could change this, right? You could, do the same thing to reduce it, right? This is the same thing as 6 over 7, right? So you could make this 6 over 7 just to make it simpler. So that's what? 7 times this equals 39 times 6. Okay? Then you got to do some algebra. And what did you end up with x? 7x minus 42 equals, what's 39 times 6?
Is it 39.4?
Well, it is, but it went as a fraction, what is it?
39 and 3/7.
39, well, 39
It
times
is
6. Okay,
90.
all right. 234. Okay, and then you're going to add 42, you get 7x equals,
I did it.
all right, there you go. $39 and 3/7, okay? All right, last one, 47. All right, what does it say? 47, scale. Okay, the ratio of one side of triangle CDE to the corresponding side of a similar triangle FGH is 2 to 5. The perimeter of FGH is 28 inches. What is the perimeter of triangle CDE, Shannon?
This was before I figured out how to do the ratio thing, so I don't think I had gotten it right. I got like 56 over 5.
Yeah.
That's right.
That's right.
Yeah.
Right.
Oh, I didn't think that was right.
Right, which is the same thing as 11 and 1/5.
Okay.
Airplane mode is an amazing
I
thing.
know. Let me see. All right, let's.
I liked that homework.
All right, let's turn this off.
Did anyone else like that homework?
Yeah.
I like
No,
having
no.
I liked
fun.
it. It was